right. Hello, everyone. We are live with our next session on labor market landscape modeling with knowledge graphs. So we have Louis and Merson with us. We're going to talk to you all for this amazing session. Over to you, folks.
Yeah, thank you, Sid. Yeah, welcome. Good afternoon, everyone. Thank you for joining us for this topic on labor market intelligence through knowledge graph. So, a quick introduction. My name is Lois, and with me today is Merson. We are data scientists in the Singapore public sector and from GovTech Singapore, the government's Center for AI Research and Capability Development. In my role, I lead a team of forward deployed data professionals working closely with SkillsFuture Singapore to harness graph technology for skills and labor market intelligence.
Hey
Merson?
everyone, my name is Merson. I've been with GovTech for over a year. Over my tenure here, I have experiences developing different knowledge graphs using Neo4j technology, mainly for public good. Today, we are excited to share with you some of the use cases we have co-developed with SkillsFuture Singapore, which is the national skills authority that drives lifelong learning and skills mastery for all Singaporeans.
So next, the labor market today that we see is constantly shifting due to innovative disruptions in the sense that skills and tasks required from individuals are changing, how companies are hiring are also changing, how businesses are operating under the influence of AI is also changing. So naturally, jobs are transforming while the skill sets of our workforce are kind of left to evolve at a much slower pace. So this calls for the need of a dynamic monitoring mechanism to track such shifts that is constantly happening in our labor market, and for more forward-looking policies to be put in place. So all of this actually forms the motivation behind our efforts to create a unified representation of the labor market data. So in this case, we are then able to provide quality recommendations on things such as career transitions or upscaling options. This information easily available to our citizens. Last but not least, the unified knowledge graph also creates a more informative view for both the human policy officers as well as AI to act upon. And in this case, we are looking at the cycle of developing, reviewing, as well as communicating labor market policies and intelligence. So next, we have a production use case in SkillsFuture Singapore, where we leveraged Neo4j to quantify similarities between various labor market entities, going beyond just having semantic comparisons, like for example the cosine similarities, by actually making it more explainable with a jobs and skills knowledge graph, which we internally refer to as the JSKG. So the JSKG also serves as our reasoning engine behind how customized career transition recommendations are generated and served out to the public. By referencing input data such as the skills framework, which is the national skills framework developed by SkillsFuture Singapore, as well as a huge repository of near real-time job posting data, and adding it on with the availability of government subsidized training courses, we are then able to form this unified view and have it presented in the form of a JSKG. Next, Merson will share with you more on this use case.
Thanks, Lois. So our job skills knowledge graph captures core labor market entities such as jobs, the skills and tasks associated with it, the sector which the job belongs to, as well as the training courses which are provided by our selected partners, such as institutes of higher learning and endorsed training partners. The jobs, skills, and task entities are extracted from job posting data using in-house machine learning algorithms and ultimately nationally standardized against the SkillsFuture taxonomy, which we all refer to as the skills framework. Sector information is labeled by human analysts, and courses offered are from our own curated list. Now for the ages, we firstly capture explicit relationships predefined in the skills framework as seen by the purple age. Following this, we include implicit relationships that are derived from labor market insights or advice given by a panel of industrial experts, as shown by the blue edges. To further add another dimension to the knowledge graph, we compute and attach weights, as seen by the red color edges, to provide us with the similarity scores and empowering downstream recommendation use cases. For this job skill knowledge graph, we unlock distinct values for different audiences. Firstly, for our analysts, This unlocks richer, relationship-driven analysis through advanced graph curving and traversal strategies. For our non-technical users, we use Neo4j Bloom. The tool provides us with a code-free visual interface for our policy planners and domain experts, empowering them to ask their own questions and thereby get their own answers. Furthermore, graph data science methodologies can be utilized to solve issues we were previously unable to address. This involves forming relationships between skills and tasks, which provides greater insights into the labor market. We achieve this by modeling the problem as a link prediction task and leveraging a graph neural network solution to discover the implicit relationships between skills and tasks. Our Neo4j hosted job skill knowledge graph serves as the backbone to various features and insights via our Singapore job skills portal. This enables the full ecosystem of users, ranging from individuals all the way to enterprises, to make decisions driven by nationally standardized data. An example highlighted on this slide demonstrates how our Singapore job skills portal assists an individual to gain clarity to potential career transition pathways, allowing them to take charge of their own career journey.
In addition to some of the existing projects on the job skills knowledge graph, we have also kept a lookout for new research work done in the space of graph relational foundation models. So in general, we see the need for existing tabular datasets to take on the form of either a semantic knowledge graph or as well as in the form of a relational schema representation in a graph. So of course, the latter allows us to directly apply graph neural networks or graph data science packages on relational datasets. So to better illustrate this, I will actually share with you a white space exploration project we are working on using pseudo data for a start. So the idea is to make prediction on individuals' probability for job transfer within a time period. And in this case, we can then go on to think about other possibilities, such as making predictions on skills that might have been missed out from, let's say, a user's profile, given his or her career history, as well as the skill sets of other similar individuals. And then furthermore, if you think about the perspective of an economic planner, we can also make predictions on job vacancies over the next X period, given the current economic performance or historical job vacancy trends. Last but not least, if let's say today we are looking at providing recommendations for the next steps of either a mid-career individual or a new fresh grad that has just entered the market, you can also predict the best option for career transition based on both the future economic outcomes as well as the current individual's skills and qualifications. So in this case, the pseudo data set listed here are what we are working on currently, but this is definitely we are not limited to the data set here. And Merson will then share with you more about some of the details that we have thought about regarding this white space.
Thanks, Lois. So graph relational foundation models represent an exciting frontier in graph development, and we have been very optimistic that it can unlock advanced predictive capabilities for labor market insights. So our labor market data, as illustrated on this slide, has traditionally been stored as a relational schema. This contains many multiple join tables as highlighted, and featuring various relationships like one-to-one and one-to-many. These join tables and foreign key linkages represent the join paths between entities in the relational model, which are usually modeled as conceptual relationships when crafting a semantic knowledge graph. To facilitate the usage of graph relational foundation model, this schema is modeled into a knowledge graph by capturing the table's entities as nodes and the primary foreign key linkages as edges, thereby creating a comprehensive graph representation of our entire relational database. Next, once the graph representation is established, we can then leverage powerful graph relational foundation models. These models are pre-trained on a vast amount of relational data, giving them a high baseline understanding of the complex, often non-obvious relationships within that data. Similar to how a large language model is adapted for diverse tasks, we can then fine-tune this graph relational foundation model specifically for our labor market domain. This adaptation ensures that us to generate predictive insights at multiple levels. Firstly, at an individual level, where we can forecast the likelihood of an employee leaving his or her job, and at the sectorial level, where we can predict the future workforce numbers within a specific industry. Ultimately, this capability gives us the greater agency to craft meaningful policies and ensure the fluidity and health of the labour market. Over the past 3 years, our GovTech and SkillsFuture team have collaborated extensively on knowledge graph projects. Our work has made notable contributions to the field, including improving relationship modeling and enriching the graph with additional intelligence. This expertise is validated through our peer-reviewed publications at many top-tier conferences, and we remain fully committed to this effort and to extracting further value from graph-represented data. All in all, within the labour market, the most valuable intelligence isn't the data points themselves, but in the relationship between them. Modeling these connections explicitly as a graph is how we move from just having data to unlocking powerful and actionable insights. This is where knowledge graphs are essential, as they turn messy, implicit webs of patterns into clean, actionable structure, thereby creating a valuable asset for us human users, analysts, as well as AI systems. With that being said, building a knowledge graph is complex. Hence, it may also be worthwhile to experiment with new technologies, like the graph relational foundation model which we mentioned, which boasts the ability to give us a quick and powerful baseline. However, the baseline is merely a starting point, and rigorous evaluations still need to be conducted, especially in our labour market context. Now we have reached the end of our sharing. If you're excited about the potential of graph technology for public good, whether it's for the labour market modelling or other applications, please feel free to connect with Lois or me to continue any conversations. Thank you so much for your time and attention today, and we truly hope you enjoyed learning about work, and do feel free to leave us a feedback.
Thank you.
Thank you.
We are now open for questions. I think we have about 3 minutes if there is any questions from the audience. Session. Thank you, Sureka. I think we have one from Henry. If we have, okay, trying in the chat, right? Okay, we have one from Hashit. Is there any existing code notebooks available? Unfortunately, we are not able to open source the current exploration, but we definitely will publish once we have completed our white space project. So I guess see you in GitHub. See, how can we evaluate the impact of skills gap on job fulfillment? Impact of skills gap fulfillment. Sorry, if you're able to elaborate a bit more, how can we evaluate the impact of skills gap? Job fulfillment. Maybe I'll just give a go on how I interpreted your question on the impact of skills gaps. So in this case, what we are trying to achieve is it means the applicant with no correct skills. Okay, so in this case, we want to go beyond just looking at a skills-based matching for job recommendations, because we know that actually skills, although it is core and fundamental to jobs, it's only a part of it. So there is also the element on work task fulfillment. So if we look at it, if let's say today you kind of are performing similar tasks, but using different skill sets, then I would then say that having the view of how your tasks are transferable from job A to job B is then something that should be taken into consideration when we do job recommendation. Yeah, and in that case, we are also trying to predict the linkage between certain tasks to skills. So in a certain sense, if today you're having a set of tasks, but you're not so sure what's the adjacent skills, the link prediction piece will then be able to form that implicit connection for you and guide you in, let's say, what are some of the skills you should actually pick up next, or what are some of the adjacent skills that you might already have today but are not yet found in your profile. Mr. P. Yeah. So today we are really trying to go beyond just looking at skills as skills alone, but also expanding beyond going into tasks, qualifications, so on and so forth. Yeah. And some of the softer skills as well. Thank you for your question. Thank you.
Thank you.